Alright, here we are at the bottom of page 1 in 4.5. And let's try some problems here. We're going to just start out with basic practice plugging pieces into the the point slope form. The instructions say to write the point slope form of the line with the given equations. So we're going to take what they give us. They're going to give us, you can expect they're going to give us a point and a slope, and we plug it into that form of the line. Then we're going to use what we've created to write the slope-intercept form of the equation, which means that we're going to then solve for y. Okay? So it's a way to get to a version of the equation. So as we're trying to memorize something, point slope form in this case, we're going to write it every time we need to use it. So it says to write the point slope form of the line. That means I'm going to see a point and a slope in it. So that clues me in that I'm going to be using, you might even label it every time, the point slope form, just to connect your brain with what it is and what it's called, because you're going to have to, on the test, do what the instructions clue you in to do. And it says write the point slope form. You're going to need to identify which one that is to be able to use it. So y minus y1 is equal to m times x minus x1. Write it and say it. You'll see it and hear it every time you use it. And they tell us that the slope equals 6, so our m value is going to be 6. And the point we're using, it passes through 3, 1. So 3 is our x1 value and 1 is our y1 value. So I'm going to rewrite my formula, leaving spaces for these three values. So it's y minus y1 equals m times x minus x1. Now I am just, this is for me. I use the parentheses so I can see where I need to put these values in. And I'm not then struggling with, well, is it plus, is it minus? Okay, the actual formula has already told me what to do. I'm subtracting that y coordinate and I'm subtracting that x coordinate. So if the parentheses are too much for you, don't worry about it. In fact, don't do them. In fact, in the next example, I'll do it without parentheses so you can see what that would feel like. Okay, and now we're going to put our values in. y1 is 1, m is 6, x1 is 3. And then we're going to work that out from there. So I get y minus 1 is equal to 6 times x minus 3. Notice what I did here is I'm not moving on with the algebra because they want two answers here. One is the point slope form of the equation. So I pause right here where it's y minus the y value equals m times x minus the x value. Okay? So that is point slope form of the equation. Now let's do our then here. Then to get slope-intercept form, which looks like this, y equals mx plus b, I would solve for y. So in this case, I need to get y all by itself on one side. I need to take care of any simplifying that needs to happen. So I've got y minus 1 equals 6 times x minus 3. I'm going to start by distributing that 6 and getting rid of the parentheses here. So y minus 1 is equal to 6x minus 18. Somebody might go, well, wait a minute, don't we want it to be, don't we want that m out there? Yes, we do. We're going to get there. Remember, we're looking for mx plus b. There's no parentheses in this final version here. So 6x minus 18, and then we're going to add 1 to both sides. And I get y equals, I'm going to slide the paper up just a little bit, give myself some room to write, y equals 6x minus 17. So there's our y equals mx plus b. If we had to graph this, we could do it instantly. We cross the y-axis at negative 17, and then we rise over run up 6 to the right 1, up 6 to the right 1, up 6 to the right 1. We have our graph. Okay, y equals mx plus b. So there were two answers that they wanted there. First one was in slope-intercept, or I'm sorry, point-slope form. Here's your point, here's your slope. Second answer was in slope-intercept form. Here's your slope, here's your intercept. So same equation, same graph. If you were to plot 3, 1 on the graph and use a slope of 6 to connect it to the next point, you'd get the same line as you would by doing slope of 6, intercept of negative 17. Okay. All right. So that's that one. Let's do this one as well. We'll do the same thing where we write the point slope first, then use that to come up with slope intercept. So 2 answers again. And this time I won't use the placeholders, and you can see what that would look like to do it that way. Okay, so once again, I'm trying to memorize point slope form. And when I'm trying to memorize something, I'm going to write it out and say it every time. Y minus y1 equals m times x minus x1. That is point slope form. And so I know I'm going to be filling in y minus our y value is equal to m times, whoops, I should have left that spot open, times x minus our x values. That's not very good. Let's do that again. Okay, so those are the pieces I'm going to fill in here. And what are those pieces? Well, here's our slope value. Our slope is -3/5. Our x1 is going to be 10 because that's the point xy, and our y1 is going to be -4. It's -4 that I'm going to be subtracting, okay? Because it's y minus whatever that y value is. So in this case, it's y minus whatever the y value is. Here's the minus. It's coming straight down, but I'm subtracting the entire y coordinate, so I'm subtracting a -4. Okay, so the y1 is the -4, and the subtraction in front of that comes from the actual formula, so I'm subtracting the entire y coordinate. My m value is -3/5, and then I'm x minus the x coordinate here, so it's x minus, the minus comes from the formula, and the x coordinate comes from the point. Okay, so our x1 is just 10 because it's positive. So x minus the 10, y minus the -4. Okay, so then we just rewrite that into, this is the first of our 2 answers here. So it becomes y minus the negative is y plus 4 is equal to -3/5 x minus 10. So we leave it in this point slope form. We leave it in this messy sort of looking version because that shows that you knew how to get it into point slope form. So there's our first version of the answers. Okay, our first answer. Okay, then to get slope intercept form, which is y equals mx plus b, we're going to solve for y. Okay. So we take our y plus 4 is equal to -3/5 times x minus 10. Let's go ahead and distribute that -3/5, and I get y plus 4 equals -3/5 x. Leave it in fraction form because you're going to want that slope look to it, that rise over run. And then -3/5 times a -10, if you need to, do it over here on the side. That's times a -10 over 1. The negative times a negative is going to become a positive. The 5 goes into 10 twice, and I get 3 times 2 over 1, which is just going to be 6. Okay, so don't panic about fractions yet. Don't try to convert everything. You could, if you wanted to, as soon as you saw that fraction, before you distribute, multiply the right side by 5 and the left side by 5. It will create one extra step at the end where you have to divide by it, because our goal is to keep y all by itself. But it is possible to do this another way, but I think you'll find that you're able to deal with the fractions. But we'll see. If you need to see it a different way, please ask in class. So subtract 4 from both sides because our goal is to get y by itself, so we can get y equals mx plus b form. So y equals, the -4 combines with the regular number. It does not combine with the x term. It's not like terms. So we still have -3/5 x plus 6 minus 4 is going to be a plus 2. So this is the y equals mx plus b form. It gives us our y-intercept where it crosses the y-axis. Here's our slope, how we'd move from it. And that creates the same line that was described as before. It passes through the point 10, -4 and has a slope of -3/5. Okay? So that is our second answer of this. 2 forms of the equation. The point slope form followed by the slope intercept form. Point slope because they just gave us any old point and a slope. Slope intercept because that's really our friend in terms of being able to see the graph and create it super quick. Okay, that takes care of that. Let's move on to the next page where we get to do some try problems. All right, we'll see you there.